Okay, so in algebra, first I will take complex numbers, then we will take some other parts of the algebra, then we will go calculus, and then finally we will go for 3D vectors, etc. You have still a lot of time. The method I will explain here first before starting the class. I will be giving assignments, because you know in maths assignments are very, very important. You have to solve all the assignments. The assignments you must solve, you must be getting through the Google Classroom. Everybody must have got the Google Classroom. On the Google Classroom, I have already placed one assignment on complex numbers. Assignments will be of two types, basic type, and once you have done the basic type, you can ask me the advanced type also. Second level, third level, different types of assignments will be there. But in the Google Classroom, generally I will putting the assignments which are very good for your speed and which are very good for mains. That is the purpose. You must be mains and CET. Your speed must be very high. So you have to focus on the speed. If given, speed is the essence. In exams, every time we are seeing that students, if time is given, they can solve number of problems, 80%, 90% of the paper. But within the given time frame, they are able to solve only 30-40% of the paper. So most of the time, the question is not of the knowledge, question is of the speed and confidence. And speed and confidence comes once you solve more number of problems in mathematics. So first assignment I have put of 100 questions. Some questions may be very easy, solve them fast. Some may be difficult, wait till I complete the chapter. While explaining the chapter here, as it is a crash course, remember, it is not long-term 2-year course. So method will be, I will be taking some examples. With the help of examples, I will be explaining theory. If some important theory is there, one or two more questions I will explain. I cannot go in this for the derivation of all the formulas. That is the first thing. Derivation of formula, etc. will not be there. Understood, everybody? So we will be solving only mainly theory part, that questions time only. So our focus will be mainly on the questions. So today I'm starting muting all now. Any doubt or anything? If anybody have anything to ask me, I'm unmuting first. You can ask me anything. Then I will mute everybody. Okay, shall we proceed further?
Yes, sir.
Yes, sir.
Okay, okay. So complex numbers. In the complex numbers, everybody knows this, I raised to power 2 is -1, I4 is 1. So one simple question I'm giving, if 1 minus I raised to power 2n upon 1 plus I raised to power 2n plus 1 is a real number, then find value of n. What is the value of n here? 1 minus I upon 1 plus I raised to power, this is a real number. So you can write this question as 1 minus I upon 1 plus I raised to power 2n into 1 upon 1 plus I. In this form we can write. And then rationalize 1 minus I upon 1 plus I multiplied by 1 minus I upon 1 minus I is equal to 1 minus 1, 1 plus I square, 1 plus I square minus 2I upon 1 plus 1. So this will be 1 minus 1 minus 2I upon 2 is equal to minus I. So this is in the form of minus I raised to power 2n upon 1 plus I. So minus I raised to power 2 is minus 1. So minus 1 raised to power n upon 1 plus I. So you can see now 1 plus I is free of n. That means for any value of n, only thing is this quantity can be positive, this quantity negative, but this quantity can never be real number. This quantity can never be real number because we cannot make, if you multiply by 1 minus I, we cannot make its imaginary part to be equal to 0. You can write 1 minus I upon 1 minus I. So this is minus 1 raised to power n upon 2 into 1 minus I. So real part will not be 0. It can be this positive, it can be negative. So here answer will be n belongs to 5. N belongs to 5. This will be answer of this question. So this was one of the example I have given for solving. Second, for example, I am taking, you must know that sum of 4 consecutive integral powers of I is equal to 0. That means if you write n raised to power I raised to power n plus I raised to power n plus 1 plus I raised to power n plus 2 plus I raised to power n plus 3. N may be anything. You can put n where n is any natural number or integer or whole number, any integer. Then this will be, for example, n is equal to 1. I plus I square plus I cube plus I4. This will be always 0. Sum of 4 consecutive powers of I is 0. Sum of 4 consecutive powers of I is 0. So just you keep on writing fast. That means from here I can have, if question is find summation of r is equal to 0 to 20 I raised to power r. This is how much. So definitely what happens when you are in speed, solving this in speed, you think there are 20 terms are there, 0 to 20. But if you consider 0 to 20, there are 21 terms. So either the first will be left or last will be left. You have to make pairs of 4, any 4. Pairs of 4 consecutive. So 4, 4, 4, 4. Total will be how many? 21. So total 21 terms are there. That means 1 plus I square plus I raised to power 20. So sum of these two 20 terms will be 0. So answer will be 1. Directly you can write in objective questions. Next concept. Next concept was additive inverse. Two things you have studied. One is additive inverse. Additive inverse of Z is minus Z. And one was multiplicative inverse of Z is 1 upon Z. These two things. Simple example on this. First, find additive inverse of 1 plus 2i upon 3 minus 4i. See, our target is finishing all this basic concepts of complex numbers and with advanced examples in 2 classes, including geometry of complex numbers. I will revise the geometry of complex numbers also in detail. So 1 plus 2i upon 3 minus 4i. So multiply this by rationalize first. 3 minus 4i upon 3 minus 4i. So this will be equal to 3 minus 4i plus 6i minus plus 8 upon 9 plus 16 is equal to 11 minus 11 plus 2i upon 25. So it's inverse. Z is minus Z. So additive inverse. So additive inverse of this will be not multiplicative, additive inverse. So additive inverse of this number will be minus 11 upon 25 minus 2 upon 25i. This is additive inverse. If asked here another question, what is the multiplicative inverse? 1 upon Z. Simply you will write 25 upon 11 plus 2i, and definitely you will rationalize again 11 minus 2i upon 11 minus 2i. So this is 25, 11 minus 2i upon 121 plus 4. So 11 upon 5 minus 2 upon 5i. This is the multiplicative inverse. So in this way we can find additive inverse, multiply inverse, etc. Now in complex number, the basic idea was, if I have a number z is equal to x plus iy, always remember here x and y always belongs to real number, and this complex number can be represented as ordered pair x comma y also. For example, if I ask you z is equal to under root of minus 3 plus under root of minus 2i, in this number, suppose, what is the real part, what is imaginary part here? So this you must write as under root 3i plus under root of 2i into I minus I square. So this is minus under root 2 plus under root 3i. So this is the real part. So real part of z is equal to minus under root 2. Imaginary part of z is equal to under root 3. So when z is equal to x plus iy, the real part of z is equal to x and imaginary part of z is equal to y. That means x and y are always real number. That you have to always, they are always real number. Different types of complex numbers are there. 3 types. If x is equal to 0, y is not 0, purely imaginary number. If y is equal to 0, x is 0 not 0, then it is purely real number and perfect complex number. All concepts, everything I am explaining fast. If anything, any doubt is there, you can ask me on chat box also. You can tell me. I will see the chat box also. Okay. If anything, any doubts are there, I have muted you, but you can continuously ask me the doubts. Now, one question: if 3 plus 2i sine theta upon 1 minus 2i sine theta is purely imaginary number. So see here, for purely imaginary numbers, real part must be 0. Real part of z is equal to 0. So what we will do, we will multiply, rationalize this. 3 plus 2i sine theta upon 1 minus 2i sine theta into 1 plus 2i sine theta upon 1 plus 2i sine theta. Now remember here, I need not to calculate everything. I will just real part of z, because this is purely imaginary. So I will just calculate the real part. Real part will be how much? 3 with 3 and I with I. So plus 4 sine theta, sine square theta is equal to 0. 3 plus 4i sine square theta is equal to 0. 3 minus, this will be minus sign, because a plus plus I square is minus 1. So 3 minus 4 sine square theta is equal to 0. Because 3 is multiplied with 3 and this 2i sine theta is multiplied this will give you the real part, others will be imaginary part. So from here, sine square theta is equal to under root 3 upon 2 whole square. And here you must know the trigonometry part also, that also I am explaining. If sine square theta is equal to sine square alpha, or cos square theta is equal to cos square alpha, or tan square theta is equal to tan square alpha. In all 3 cases, your answer is theta is equal to n pi plus minus alpha. This will be the answer in all 3 cases. Theta is equal to n pi plus minus alpha. So in this case, alpha is equal to pi by 3. This is 2. So theta is equal to n pi plus minus pi by 3. This will be your general solution of the equation. In between, I am unmuting so that if any doubts are there, you can ask on this also, or you can ask on the chat box. Very simple thing I'm explaining in the beginning. Slowly, we will move further.
Huh?
Yes. Yes, ask me. Who is asking? Yes, you can put on the chat box also. Chat box is there on the, see on the bottom side. If you are not able to speak, you can ask me in the chat box. Tell me.
No, in the denominator.
Yeah. We will get 1 plus 4 sin square theta. Yes, speak. In the denominator, we will get 1 plus 4 sin square theta. That is not required because it is equal to 0. See, this will be like this. 3 minus 4 sin square theta upon 1 plus 4 sin square theta plus I. Some terms will come. Now, this is purely imaginary. That means this real part must be 0. So this I am equating equal to 0. Understood, or still doubt is there? See, I put one message on the chat box. Yes, you can also type and ask me. You have to unmute from your side. Yes.
Yes, sir.
Understood? Hello?
Yes, sir. Understood.
Okay, good. Okay. So I'm moving further. I'm muting all again. See, complex numbers, representing of complex numbers. Complex numbers can be represented in different ways. I'm not dealing all important ways only I'm explaining. Complex number Z is Z equal to X plus IY standard form. Then this can be written as ordered pair XY, and because of this, full coordinate geometry comes into play, and this can be written as polar form R cos theta plus I sin theta. This you have done in the 11th class, where theta is the argument of complex number. This polar form just I am explaining here. And along with polar form, I will explain you one more form. If you have not done, you can study now. Euler form. Z is equal to R e raised to power I theta. That means Z is equal to R. R is nothing but mod Z. E raised to power I theta is a argument of Z. In this way we can write. So for polar form, I'm just explaining one step how to represent polar form. There are two ways are there: polar form, principal, and just argument. Principal form and general. So argument of a complex number if always positive, if measured in anti-clockwise direction from positive x axis. Otherwise, it is taken as in clockwise direction, we take it negative. So there are two ways are there measuring this. One is a general form, one is a principal form. So general form, general value of argument, general value when theta belongs to 0 to 2 pi. Principal value when theta belongs to minus pi to pi. This is the difference. A simple method you can remember here is you can note down, keep on writing. Everybody must be sitting with a pen and a copy so that you can keep on writing. Short forms I'm giving. This will be thorough revision of your all concepts. Remember, in 2 hours we will do thorough revision. Afterward, you can solve any question, particularly mains level. That much I can tell. Okay, once you attend my class, you can solve all the questions up to mains level minimum. CET level definitely you can solve any question. So after this, in this the general value. For general value, what happens? This z is equal to x plus iy. Z is equal to x plus iy. Any complex number is there? This is r cos theta plus I sin theta. This in short I will be writing as r cis theta also. C stand for cos, I plus S stand for sin cis theta. So here r cos theta is equal to x, r sin theta is equal to y. Okay, so this tan theta from here, tan theta is equal to y upon x. Depending on whether x and y are positive, negative, first what we'll do, check the quadrant. X, y, positive, negative, we know how to check the quadrant depending on x and y. Second thing is, depending on the quadrant, we will calculate now tan phi. Some term we will calculate y upon x. Forget this, this is not theta. Now depending on the quadrant, two diagrams I am making. First one is for general value, second one is for principal value. This is for general, this is for principal value of argument. What we have to calculate? So this theta, whatever theta we have, this phi we have measured is basically from the positive x-axis. So if my theta is in the first quadrant and this complex number first quadrant, this is the theta. In second, this phi, sorry, this is the phi. In second quadrant, this is the angle phi. If this line, this is the angle phi. In fourth quadrant, this is the angle phi. What this phi angle I am talking about. Similarly, in this, phi is same. This phi will not change. What will change? The way we measure the theta. For general value, what is the theta that I am explaining? Theta is this, same theta. In second quadrant, this is the theta. In third quadrant, we will measure in anti-clockwise direction only. This is the theta. In fourth quadrant, this is the theta. So now, with that, you can find the relationship between theta and phi very easily. In first quadrant, theta is same as phi. In this quadrant, this value, the second quadrant, this is the value I am interested. So this is how much total is pi minus phi. So theta is equal to pi minus phi. In this, theta is equal to pi plus phi, because this I am interested in this. And in this last, theta is equal to 2 pi minus phi. This is the fourth quadrant. But here method will be slightly different. This is the theta, first quadrant. Second quadrant, no problem. Problem comes in third and fourth quadrant. In fourth quadrant and in third quadrant this. So here first quadrant we have no problem. Theta is equal to phi. Second is also same. Theta is equal to pi minus phi. But in this, theta is equal to, this is phi minus pi. Just remember this. Pi minus phi with minus sign, because it is, and theta is equal to minus phi, because we are measuring in, if my complex number is in third and fourth quadrant, then I measure in opposite direction, clockwise direction, because magnitude must be smallest. So this is small thing you have done in the 11th class, just revision of that. Okay, just I'm revising all the concept as I told. So next point is this, I think you have noted, you already know, I think this most of these things. So see, the important thing again is writing in polar form. Suppose we have z is equal to minus 1 plus I. Then mod of z. Mod of z is always under root of real part of z. X square plus sine y square. Always they are added by plus sign. So this will be under root of 1 plus 1 is equal to under root 2. Now check which quadrant. X negative, y positive. Second quadrant. So phi. and phi is equal to mod y. 1 upon minus 1 is equal to 1. So phi is equal to pi by 4. So in second quadrant, theta will be pi minus pi by 4 is equal to 3 pi by 4. So this we can write z is equal to r under root 2 cis 3 pi by 4. This is the polar form. Now one important thing here, in polar form, this is not unique. That means sine theta plus cos theta. This is not unique. That means after every interval, because here the angle argument is not unique. After every interval of 2 pi, it will repeat. So this is not unique. The same number I can write in this Euler form as under root 2 e raised to power I theta. Theta is how much? Theta is 3 pi by 4. In this form also I can write. So this is the representation in Euler form or this form. After this comes next De Moivre's theorem. So I'm revising all the concepts very fast so that I can concentrate more time on the geometric applications of the complex numbers. De Moivre's theorem. In the De Moivre's theorem, here two statements will be there. You have to be very careful of that. De Moivre's theorem for integral index and De Moivre's theorem for any index. De Moivre's theorem for integral index and De Moivre's theorem for any index. First, De Moivre's theorem for integral index. That means cos theta plus I sin theta raised to power n when n belongs to set of integers. This is equal to cos n theta plus I sin n theta. This proof is very easy with the help of Euler's theorem, e raised to power I theta raised to power n. This is a e raised to power I theta raised to power n is equal to e raised to power I n theta. Whatever, if I ask you e raised to power I 3, this is a cos 3 plus I sin 3. Remember here, I theta, theta must be in radians. Theta must be in radians. Now its other forms, cos theta plus I sin theta raised to power minus 1 will become cos theta minus I sin theta. Remember, this must be cis theta, cos theta plus I sin theta form. If question is sin theta plus I cos theta, sin theta minus I cos theta, then you have to convert in standard form. That will not be your standard. De Moivre's theorem will not be applicable. Or if it is cos theta minus I sin theta raised to power minus 1, this will be converted cos theta plus I sin theta. The problem comes when this power is fraction. For example, if I ask you one question, find minus 1 plus I raised to power 3 by 4. Now how to solve? How many solutions will be there? Just listen again, everybody, carefully. Now its answer will depend what is the denominator of this 3 by 4. So whenever this is in the form of P upon Q, so this here cos theta plus I sin theta, I'm explaining this in detail. Okay. The method is, first I will write this in general form, polar form. And I have already written polar form of this. Here this cos theta z is equal to minus 1 plus I. So this number is equal to under root 2 cos 3 pi by 4 plus I sin 3 pi by 4 raised to power 3 by 4. Now one word of caution here. When this power n is any index, n does not belongs to set of integers, then first you must, listen again, first we must write the most general form of this argument. Directly I cannot apply the Demoivre's theorem because this equation will have 4 roots. So what I must do, I must write this as under root 2 cos. Most general form is at 2k pi, because we know sine 2k pi plus theta is same as sine theta, cos 2k pi plus theta is also cos theta, plus 3 pi by 4 plus I sine 2k pi plus 3 pi by 4 raised to power 3 upon 4. Now what is k? K is 0, 1, 2, 3. P minus, this denominator is up to 4. I will take up to 3. P minus 1. P upon Q means Q minus 1. If this is denominator is supposed like 7 upon 10, I will go to 0 to 9. So for these 4 values of K, I will get the 4 roots. So if K is equal to 0, I will get one root under root 2 cis 3 pi by 4. This is one of the solution. K is equal to 1. If K is equal to 1, I will get under root 2 3 pi by 4 power 3 by this 3 by 4. Okay, 1 minute I will do. I just this. Now after this, what we will do? We must simplify this. So this is equal to 2 raised to power 3 by 8 cos 4 to the 8 k plus 3 pi by 4 plus I sine 8k plus 3 pi by 4 raised to power 3 by 4. Now we can apply the Demoivre's theorem here. So this will be 2 raised to power 3 by 8 cis 3 pi by 16 8k plus 3, where k is equal to 0, 1, 2, 3. So for those values, I will get the 4 roots. So I'm unmuting. If anybody have doubt in this process, you can ask me. I think most of you must have done this part.
Yes, sir, no doubt.
Okay. So I am proceeding further. Okay. For k is equal to 0, we will get one root. For k is equal to 1, we will get another root. These are the 4 values of k. So in this, we will put the 4 values of k, cis. Next point. Next point is coming to cube roots of unity. After this, cube roots of unity. This everybody must remember the cube roots of unity. This z is equal to 1 raised to power 1 upon 3. So z cube is equal to 1. So z minus 1 into z square plus z plus 1 is equal to 0. That means z is equal to 1, or z square plus z plus 1 is equal to 0. And if we solve, you know, this is d is my imaginary. So we solve, we will get the complex roots. So this solution is 1, this solution is omega and omega square. So from here, z is equal to minus b plus minus under root b square minus 4ac minus 3 upon 2. So this is minus 1 upon 2 plus minus under root 3 I upon 2. So omega is equal to minus 1 upon 2 plus under root 3 I upon 2, and omega square is equal to minus 1 upon 2 minus under root 3. Although they can be interchanged also, this is not fixed. So these are our cube roots of unity. Their important properties are cube roots of unity. Some very important properties of cube roots of unity. First of all, omega cube is equal to 1, but omega is not equal to 1. This you must be very careful. And polar form, also you must remember omega its argument is equal to mod of omega is equal to mod of omega square is equal to 1. So omega can be written as e raised to power I 2 pi by 3, and omega square can be written as e raised to power I minus 2 pi by 3 or e raised to power I 4 pi by 3. In this form we can write. We can find those polar form we can convert, but if we remember then it is better. Third thing is omega is a root of this equation, so omega must satisfy this. That means 1 plus omega square is always equal to 0. Fourth important property is they form an equilateral triangle. 1 omega square lies on vertex of equilateral triangle. What kind of triangle they will form? If you observe here, this is 1. Omega argument is 2 pi by 3. So this will be omega here. This is 2 pi by 3 angle. And this will be omega square. 2 pi by 3 again. So we will form a triangle here like this. 1 omega square. This green color I am making. So they form equilateral triangle. They are the vertices of equilateral triangle. Inscribed in a unit circle. You can write further. Inscribed in a unit circle. Like this. Inscribed in a unit circle. That means this triangle can be inscribed in a unit circle. Radius of this circle R is 1. That is the meaning of this. Now, after this, we can move for the nth roots of unity also. And then we will move for factors and geometrical problems. So, in the cube root of unity, one very important concept I am giving here. Because so many questions will come on these concepts. First concept is a question type will be whenever this is given that, for example, any cubic equation is given and it's one of the real root is p, then other roots will be p omega and p omega square. If one of real roots of a, this is note, very important note, you must note down. If one of the real roots of a cubic equation is p, then other roots will be p omega and p omega square. For example, if you have x cube plus 8 is equal to 0, what are the solutions of this? So you can write x cube is equal to minus 2 cube. So one root is x equal to minus 2. So other roots will be minus 2 omega minus 2 omega square. In this form, you can find the solutions. Once one question was asked on this, that question was solve the equation x cube minus 3x square plus 3x plus 7 is equal to 0. This is from your exam problem. Solve x cube minus 3x square plus 3x plus 7 is equal to 0. So if you are not careful enough, it will be very difficult to identify whether it belongs to complex number or simple equation, how to find the roots. But in choices, omega, etc. was given. So by that you can give, okay, it is complex number problem. So what to do? In this, if you are careful enough, you can write this as x cube minus 3x is outside, x cube minus 3x, x minus 1. So minus 1 plus 7. That means you can write x cube minus 1 cube minus 3x into x minus 1 is equal to minus 8. So this is x minus 1 whole cube is equal to minus 8. X minus 1 whole cube is equal to minus 8. This is equal to minus 2 whole cube. That means x minus 1 is equal to minus 2 mega minus 2 mega square. So these are the roots. From here you can get the roots of this. So x is equal to minus. So these are the roots basically. Now it's a modified question once again. They have asked another problem based on the same concept. Now in another year, see how they are changing the questions. In another year, they asked another question in the advance. If alpha, beta, gamma are roots of x cube minus 3x square plus 3x plus 7 is equal to 0, then find value of alpha minus 1 upon beta minus 1 plus beta minus 1 upon gamma minus 1 plus gamma minus 1 upon alpha minus 1 is equal to how much? This is next level problem. So in this, definitely you are not supposed to find the roots. You start finding roots and then put the value. It is not possible. So what concept you have to use? You have to use this step very carefully. Up to this step, both questions are same. That's why I told this is next level problem. Afterward, this alpha, beta, gamma are roots of this. Alpha, beta, gamma are its roots. So they must satisfy. So alpha minus 1 is how much? Alpha minus 1. You can write minus 2, beta minus 1 is equal to minus 2 mega, and gamma minus 1 is equal to minus 2 mega. These values you put here, you will get the answer. So what you will get? Alpha minus 1 is minus 2 upon beta minus 1 is minus 2 mega plus beta minus 1 is minus 2 mega square plus, and this is how much? Gamma minus 1 is minus 2 mega square upon minus 2 alpha minus 1. So this is equal to 1 upon omega plus 1 upon omega plus omega square. So this is equal to 3 omega square is the answer, because 1 upon omega is omega square. So this is the answer, 3 omega square. Omega square value you can put. Now one more type I have told, whenever, this is one part, one type of questions on this. Second type of problem is when, second important concept is second type, when ratio between real and imaginary parts is plus minus under root 3 into 1 or 1 into plus minus under root 3. Convert in omega form. Convert in, then we must convert the question into omega form. For example, if it is under root 3 upon 2 plus I upon 2 raised to power 5 minus under root 3 upon 2 minus I upon 2 raised to power 5. Even this 2 is not there, then also we can solve by the same method. So now you must remember what is omega, what is not omega. So in this case, this I is at wrong place. So what you can do, first multiply with I inside and divide. So you can write 1 upon I5, then multiply by I. So if I multiply by I, this is minus 1 upon 2 plus under root 3 I upon 2 minus, again here multiply by I and divide by I. So you will get minus minus plus 1 upon 2 plus under root 3 I upon 2 raised to power 5. So this is I for 1 upon I. This is 1 upon I. 1 upon I is how much? 1 upon I is minus I. So minus I into this, if you remember, minus 1 upon 2 plus I upon 2 is nothing but omega. Omega raised to power 5. This is I square plus I. This is minus omega square raised to power 5. Because omega square is minus 1 upon 2 plus root 3 I upon 2. Now you can solve it further. Minus I take common and solve it. So what you will get here, minus I take common, you will get omega 5 plus omega 10 is equal to minus I, omega cube is equal to 1. Always remember omega cube is equal to 1. So omega square plus omega. Omega square plus omega is minus 1. So this is equal to I. That will be answer of this. Omega square plus omega is equal to 1. Minus 1. So minus 1 into minus I is equal to I. That is the answer of this question. So understood this? Any doubt up to this? Okay, so next point. One more question I'm giving of same type. This also your previous problem only. If omega is complex root of unity, then find value of solve a plus b omega plus c omega square upon c plus omega plus b omega square plus a plus b omega plus c omega square upon b plus c omega plus a omega square is equal to. Now here also this question is also very simple. In this, what you have to do, you have to just observe numerator and denominator. In this, if you multiply and divide both numerator and denominator by omega square and 1 upon omega square. So omega square is outside C now. Numerator as it is, a plus b omega plus c omega square. Denominator will be c omega square plus a omega cube is a plus b omega plus similarly a plus b omega plus c omega square. In this case, it is b omega square a omega. So in this particularly, for this is for this, and for this you have to multiply and divide by omega upon omega. So omega is outside here, and this will be omega multiply. So b omega plus c omega square plus a. So this will cancel out, this will cancel out. So answer is omega plus omega square is equal to minus 1. Omega plus omega square is equal to minus 1. So we can solve in this way. Okay, so these are some important problems, previous guys problems, which are very important, which I have discussed. Next comes the nth roots of unity. Nth roots of unity. Like cube roots of unity, we have 1 omega omega square. Similarly, here nth roots of unity, z is equal to 1 raised to power 1 upon n is equal to z. This one is cos 0 I plus sin 0. But instead of 0, we write 2k pi. So cos 2k pi plus I sin 2k pi raised to power 1 upon n. This is nothing but e raised to power I 2k pi upon n. So what will be k? depending on this. In the previous one question I have told, when 3 upon 4, k was equal to 0, 1, 2, 3, because here we must get n roots. So k will be equal to 0, 1, 2, 3 up to n minus 1. For these values of k, I will get the n roots of unity. So those n roots of unity will be what? If now important thing in this case is that those n roots of unity will be 1. If I put k is equal to 0, it is 1 e raised to power I. K is equal to 1, 2 pi by n. K is equal to 2 e raised to power I, 4 pi by n, etc. So if alpha is equal to e raised to power I 2 pi by n. See, like omega we have assumed, so here we are assuming this to be alpha. If n is equal to 3, alpha is nothing but omega only. So roots are 1, alpha, alpha square, alpha cube, up to alpha n minus 1. These are the nth roots of unity. Now here very important question comes on nth roots of unity. This is very big topic, and so many times if you find questions are based on this nth roots of unity concept. Some properties are there and some formulas which I am giving you now discussing. Everybody must listen this carefully, because this is a very important topic now. Slowly we are entering into complex numbers. First concept is nth roots of unity property. Sum of nth. Okay, before that write some property. This properties. 1. Alpha raised to power n is always equal to 1, but alpha is not equal to 1. Because what is alpha? We have seen alpha is e raised to power I 2 pi by n. Alpha is a complex root. It is not real root. Alpha is a complex root. Second thing is sum of nth roots is always equal to 0. Whether we talk about the 3 roots, 1 plus omega square is 0. Whether we talk about 4 roots or 5 roots or 10 roots, sum of nth roots is always equal to 0. Third is product of nth roots. Product of nth roots is equal to minus 1 raised to power n minus 1. Derivation of this, multiply 1 alpha square into alpha raised to power n minus 1. So this is a alpha raised to power 1 plus 2 plus 3 up to n minus 1. This is alpha. Alpha is how much? E raised to power I 2 pi by n raised to power. Sum of n minus 1 natural number. So n minus 1 into n upon 2. So this n upon 2 will cancel out. This n will cancel n, 2 will cancel 2. So e raised to power I pi. This is a cos pi plus I sin pi raised to power n minus 1. So this is equal to minus 1 raised to power n minus 1. This is the derivation of that. Minus 1 raised to power n minus 1. So product of nth roots of unity is equal to minus 1 raised to power n minus 1. This is clear?
Yes, sir.
Yes, sir.
Now see, some other important aspects about this n roots of unity I am giving now. Like cube roots of unity lie on a triangle. So one point is a nth roots of unity. Nth roots of unity form n-sided regular polygon inscribed in a unit circle. Nth roots of unity form n-sided regular polygon inscribed in a unit circle like this. And this is 1 alpha, alpha square, alpha cube, alpha square. This is alpha n minus 1. This, like this. If n is equal to 3, that polygon is triangle. If n is equal to 4, that polygon is a square. If n is equal to 5, that is a pentagon, and so on. One very important point, next point is if roots are, if z raised to power n minus 1 is equal to 0 has roots 1 alpha, alpha square, alpha cube, alpha n minus 1, then 1 upon alpha square, 1 upon alpha cube, 1 upon alpha n minus 1 are also its roots. Because fz is equal to 0 is same as the equation f1 upon z is equal to 0. The reason is fz is equal to 0 is same as f1 upon z. So by replacing z with 1 upon z, we are getting same equation. So original equation is having say root alpha beta gamma, then 1 upon alpha, 1 upon beta, 1 upon gamma will also be its roots. Second important concept, next third important concept is just example I am taking. All complex roots always occur in conjugate pairs. This complex roots always occurs as conjugate pairs. Complex roots always occurs as conjugate pairs. For example, when n is equal to 3, what were the roots? 1 omega square. So omega square, this can be written as 1 omega square can be written as 1 omega bar also. Both are same. They are the conjugate of each other. Similarly for 4 root, 5 root, or any other root. So in general, if suppose 5 roots are there for n is equal to 5, you can write 1 alpha square, alpha square bar. These will be the roots. Complex root I am telling, real roots are there, suppose, then 1 or minus 1 will be the real roots. Other complex roots will be always conjugate pairs. This point is very, very important because once a very good question has been asked on this, I am taking that problem. So question is, if alpha is equal to e raised to power I 2 pi by 11, then find value of the real part of alpha plus alpha square plus alpha cube plus alpha 4 plus alpha 5. This is how much? This is the question. Just solve it. First time this question was asked in IIT Advance.
Does it minus half?
Yeah, correct. Very good. So in this question, first time it was asked, it was a very difficult problem. Now it is available. So what is the concept here? We have to apply this concept only. Because here, see, the important thing is if you observe this is a very important thing here. This, if you, what was the e raised to power I 2 pi by n. Alpha was e raised to power I 2 pi by n. So here n is equal to 11. So n is equal to 11 indicates that we have something to do with the 11 roots of unity. N is equal to 11. And that's sum of the 11 roots. 1 plus alpha square plus alpha cube plus alpha 4 plus alpha 5. Now, the remaining 5 will be conjugates. Alpha bar plus alpha square bar plus alpha 5 bar must be equal to 0. So now real part. This gives me that we know z plus z bar is nothing but 2 times of real part of z. So from here we will get alpha plus alpha bar. You can form the pairs. Alpha square plus alpha square bar plus and so on. Alpha 5 plus alpha 5 bar is equal to -1. So this gives 2 times of real part of alpha plus alpha square plus alpha 5 is equal to -1. So this implies real part of alpha plus alpha square plus alpha 5 is equal to -half. This is the answer. So those who don't know can note down this. Now here 2-3 simple points I will give you. You must note down them. They are very useful while solving the problems. Okay, so next point is if I ask you this, see, these are very important for solving the objective questions. Directly they are asking this type of questions. Summation of, for example, if I ask you summation of k is equal to 0 to 1 cos 2k pi by n plus I sine n minus 1. 2k pi by n is equal to, this is equal to 0. You can remember this. I will explain how this is coming. Remember, here n can be any number. N can be 10, n can be 20, n can be 30. So many questions can be framed. If you put n is equal to 10, k is equal to 0 to 9. So the idea here, this cos e raised to power I 2k pi by n, this is nothing but a summation of e raised to power I 2k pi by n 0 to n minus 1. So this is nothing but alpha 1 plus, because when I put 0, this will be alpha. If it is 0, k is equal to 0, it is 1. So 1 plus alpha plus up to n minus 1 is equal to 0. But sometimes they will give that k is equal to 1 to n minus 1. Cis 2k pi by n. So now in this case that k is equal to 0 is missing. That means we are having n minus 1 terms. So this one will be missing. This one will not be there. So this will be equal to -1. We will send it to right hand side. Okay. Now, based on this, there are 2-3 problems are there, which I'm again explaining. Those problems are this x raised to power n minus 1 can be written as x minus 1, x square minus 1, x minus 1, x minus alpha, because these are the roots of this. These are the roots. So x minus 1, x minus alpha, x minus alpha square, x minus alpha raised to power n minus 1. Remember one thing here, it is not necessary that this is represented as alpha square. Sometimes they represent alpha 1, alpha 2, alpha 3, alpha n. So you have to understand that what is the meaning, what he wants examiner. What is the meaning of alpha 1, alpha 2, alpha 3? Because these are the nomenclatures. So they can be changed. Now, sometimes they ask find. Two questions I'm taking. Find value of 1 minus alpha, 1 minus alpha square, 1 minus alpha raised to power n minus 1. So in this case, here's right, you have to be careful. From this first line, this is very clear that I can put x equal to 1, I will get most of the term. But it is 0, 0, 1 minus 1, 1 minus 1 is there. So I can write x minus alpha square, and x minus alpha raised to power n minus 1 is equal to x to the power n minus 1 upon x minus 1. Now we can put x equal to 1. So 1 minus alpha square, 1 minus alpha raised to power n is equal to. Now right hand side I cannot put x equal to 1, but I can take limiting case. Limit x tends to 1. So x raised to power n minus 1 upon n, because it is 0.04. So this will be equal to n. Instead of 1, if I put any number, I will get the direct answer. For example, if you put n is equal to 3, then directly you can get 3 minus alpha square, 3 minus alpha raised to power n minus 1 is equal to 3 raised to power n minus 1 upon 2. This will be the answer. So in that case, we need not to take the limit. But in case of n is equal, this x equal to 1 only, I have to take limit. Why? Because this right hand side, this side becomes 0 upon 0. If x is not equal to 1, this is not 0 upon 0 form. Note down this. Some more points I will explain. Okay. So next, sometimes they may ask questions in denominator also. So I'm explaining that concept with the help of some examples, how we have to solve. So x raised to power n minus 1 roots are x minus 1, x minus alpha, x minus alpha square, x minus alpha raised to power n minus 1. Now, when to bring them in denominator, what we will do, we'll take log on both sides. So log of x raised to power n minus 1 is equal to log of x, log AB. Log AB is log A plus log B plus log of x minus alpha plus log of x minus alpha square plus and so on. Now if I differentiate, I will get the terms in the denominator. So n x raised to power n minus 1 upon x raised to power n minus 1 is equal to 1 upon x minus 1 plus 1 upon x minus alpha. Derivative of x is 1 plus 1 upon x minus alpha square plus 1 upon x minus alpha raised to power n minus 1. Now you can put x equal to any number, 2, 3, 4, any number. X you can put 2, 3, 4, whatever is there. Suppose this x equal to 3. Then you will get n 3 raised to power n minus 1 upon 3 raised to power n minus 1 is equal to 1 upon 2 plus 1 upon 3 minus alpha plus 1 upon 3 minus alpha square plus and so on. So 1 upon 3 minus alpha plus 1 upon 3 minus alpha square plus 1 upon 3 minus alpha raised to power n minus 1 is equal to n 3 raised to power n minus 1 upon 3 raised to power n minus 1 minus 1 upon 2. This will be answer of this. Note down if anybody want to note. So these are all very difficult problems which can be asked in your exams. Now here x can be any number except 1. See the assignment I have given, that is also very simple assignment. Most of questions you will solve. And I have given the solutions also of the assignment. The purpose is you must do a lot of practice. So solve the assignments along with practice. Maths requires practice only. Okay. So I'm coming to next. Now, some other questions related with this. So I'm taking one or two more problems how we can solve one particular type. Okay, let us come to first factorization. There are certain important factors which everybody must remember by heart, because while solving further problems, they will be required. You have to apply them directly. So those some important factors are there. Those I'm writing important factors. First, x square plus a square can be written as x plus ai into x minus ai. X square plus a square can be written as x plus ai into x minus ai. Second factor is x cube plus a cube. Now this is cubic factor. It will have three factors. Two factors we already know. X square, x plus a into x square minus ax plus b square. Now the problem is this last step is also having two factors. This is also having two factors. So you must remember that x square minus ax plus a square is equal to a omega plus b omega square into a omega square plus b omega. So these are the three factors of this. If xq minus aq is there, then minus will be there. See, x cube minus a cube. Method is very simple. This is not only that, this is the only answer of this. This can have different answers. All answers I am giving okay to you. Okay, what are the answers of this a cube plus b cube? So I am giving all answers of this, or how to get the answers of this. That the method also I am explaining. Leave that so that you need not to remember. So this means x cube is equal to minus a cube. So x equal to minus a omega minus a omega square. So x plus a plus a omega into x plus a omega square. This factor can also be written x omega plus a omega square. In that form also you can write. One more form is there. If you want to write that form is because in exam they can ask in different forms. That is the reason. x plus a, x omega plus a omega square, and x omega square plus a omega. This is also correct form. This can be written in this form. Similarly, another one very important factor on which number of time question have been 2-3 times at least in IT advanced also. Question have been asked in different chapters is x aq plus bq plus cq. That your standard form. aq plus bq plus cq minus 3abc. So this can be written as a plus b plus c into a square plus b square plus c square minus ab minus bc minus ca. This you already know. Now last also we can factorize in 3 different ways. So this total 3 different ways will be there. This is one of the way. This multiply by 2, divide by 2. 1 upon 2, a plus b plus c. This can be written as a minus b square plus b minus c square plus c minus a square. 2 times a question has been asked on this because this bracket is always positive. So its sign will depend on ABC. If ABC are positive, this will be always positive. If ABC negative, this will be always negative. And one more factor is there, that is a plus b plus c. Now this is quadratic expression. See, this is quadratic expression. This quadratic expression, factors of this are also very important. A plus b omega plus c omega square into a plus b omega square plus c omega. So these are the factors of important factors which are very useful for solving the problems. This is over. Next. Now I'm taking one very important type of question where we will be using the mixed concepts of algebra and complex numbers. Question, this is also very important model. Question is, if A is equal to or if cos alpha plus cos beta plus cos gamma is equal to 0 and sin alpha plus sin, this note down this question, very important. I will explain so many concepts from this. Plus sin gamma is equal to 0. This is the condition given. Then prove that. Then prove that 1 cos cube alpha plus cos 3 alpha, sorry, this is a cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 cos alpha plus beta plus gamma, like this. So many answers will come of this. Cos 2 alpha plus cos 2 beta plus cos 2 gamma 0, etc. I will explain all those answers, so I'm leaving some space for writing that. Method of solving of this very important model, we will consider three complex numbers. Let Z1 is equal to cos alpha plus I sin alpha. Z2 is equal to cos beta plus I sin beta, and Z3 is equal to cos gamma plus I sin gamma. Now tell me what will be the value of Z1 plus Z2 plus Z3 is equal to 0, because cos alpha plus cos beta plus cos gamma is 0. Sin alpha plus sin beta plus sin gamma is 0. Now use the identity. If a plus b plus c is equal to 0, aq plus bq plus cq is equal to 3abc. Using that identity, just I have explained in the previous slide, aq plus bq plus cq minus 3abc is a plus b plus c into something. So if a plus b plus c is 0, then aq plus bq plus cq. So using the identity, if a plus b plus c is equal to 0, this implies aq plus bq plus cq is equal to 3abc. This identity we have to use. Now Z1, so this implies that Z1 cube plus Z2 cube plus Z3 cube is equal to 3 Z1, Z2, Z3. Z1 cube, from here you will get Z1 cube. Z1 cube will be how much? Using De Moivre's theorem, cis 3 alpha. This implies Z2 cube is equal to cis 3 beta. This implies Z3 cube is equal to cis 3 gamma. Everybody understanding this?
Yes, sir.
Any doubt anybody having? You can ask me. I have unmuted. Okay. So now, right hand side. Right hand side is what? 3Z1, Z2, Z3. So check Z1, Z2, Z3. Again, De Moivre's theorem we have to use. Cis 3 alpha, cis 3 beta into cis 3 gamma. So what happens in this case? This will be cis of 3 alpha plus 3 beta plus 3 gamma. So Z1 cube plus Z2 cube plus Z3 cube. So cos 3 alpha plus I sin 3 alpha plus cos 3 beta plus I sin 3 beta plus cos 3 gamma plus I sin 3 gamma. This is equal to 3 times of cos 3 alpha plus 3 beta plus 3 gamma plus I sin 3 alpha plus beta plus gamma. So from here, this will be 3 here. So from here you will get, so real part is equal to real part, imaginary part is equal to imaginary part. So real part is cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 cos of Z1, no, slight mistake I think I have done here. This is 3 is not there. That was the correct. This was the cos only. So here in this case, this 3 is not there because it is Z1, Z2, Z3 simply not. So this part is a cis alpha, cis beta, cis gamma is equal to cis alpha beta gamma. Cis alpha plus beta plus gamma. So this 3 will not be there, 3 term. So this is equal to 3 times of cos alpha plus cos beta plus cos gamma. Cos alpha plus beta plus gamma plus I sin alpha plus beta plus gamma. Afterward, what you have to do? Just compare the real part with real part, imaginary part with imaginary part. So real part is a cos 3 alpha plus cos 3 beta plus cos 3 gamma is equal to 3 cos alpha plus beta plus gamma. Sin 3 alpha, the imaginary part, plus sin 3 beta plus sin 3 gamma is equal to 3 sin alpha plus beta plus gamma. This is one part of this problem. This understood? Now, as I told, this question is having number of parts. Sometimes they ask questions in terms of alpha minus beta or 2 alpha. Then one more relationship you have to derive here. That also I'm explaining. So many questions I will explain with the help of this single concept. If you calculate 1 upon Z1 plus 1 upon Z2 plus 1 upon Z3, using De Moivre's theorem, this will also be cos alpha minus I sin alpha, cos beta minus I sin beta, cos gamma minus I sin gamma. If you add, this is equal to 0. So this gives that, take LCM, Z1 Z2 plus Z2 Z3 plus Z3 Z1 is also equal to 0. Now, second relationship you can get Z1 Z2. What is Z1 Z2? Cis alpha plus beta plus cis beta plus gamma plus cis gamma plus alpha is equal to 0. So from here we will get real part is 0, imaginary part is 0, cos alpha plus beta plus cos beta plus gamma plus cos gamma plus alpha is equal to 0, or sine. This is one question from here. See, as I told, afterward this chain reaction starts like this. It is like chain reaction. One more concept you can get. If you are observing here, Z1 plus Z2 plus Z3 whole square is equal to Z1 square plus Z2 square plus Z3 square plus 2 times of Z1 Z2 plus Z2 Z3 plus Z3 Z1. Now, this Z1 plus Z2 plus Z3 is 0. This is also 0. We have already proved here. So this gives that Z1 square plus Z2 square plus Z3 square is equal to 0. And again apply the De Moivre's theorem. So we'll get cis 2 alpha plus cis 2 beta plus cis 2 gamma is equal to 0. Z1 square is nothing but cos 2 alpha plus I sin 2 alpha. So third relationship you will get cos 2 alpha plus cos 2 beta plus cos 2 gamma is equal to 0. Same relationship, instead of cos, you could have used the sine also. In this concept, everybody understood this all concepts? Just note down this, whatever I have given. So just one small part I am giving, properties of modulus and argument. Okay, after that we will finish the class. Properties of modulus and argument. Properties of modulus. So mod z is equal to under root of x square plus y square. Z bar is equal to mod z square. This is very important. Z bar is equal to mod z square. Z1, Z2, Z3 mod. You can write Z1 into Z2 into Z3. Similarly, Z1 upon Z2 can be done as mod of Z1 upon mod of Z2. Remember, mod of Z is equal to 0 if and only if x equal to 0, y is equal to 0. That means for a complex number 0, complex number 0, real part and imaginary part are 0. Otherwise mod z will never be equal to 0. Mod z is always positive. Mod z represent distance. Mod z represent distance of the point or length from origin. Mod z represents, that is why under root x square plus y square. Next, this mod of z1 plus z2. This is very important. This is always less than mod of z1 plus mod of z2. Basically this gives the max. From here we are getting the concept of greatest and smallest values. So mod of z1 plus z2 is always less than mod of z1 plus mod of z2, and this is always greater than mod of z1 minus mod of z2. This gives the least value, and this gives the, although in general we go for geometrical interpretations of all this, we don't use generally these methods for solving this type of problems. Second concept you must remember that this was the one, this was the second point, this was third point, this was the fourth point, this was the fifth point, this is sixth point. 7 point is mod of z bar is equal to mod of z is equal to minus mod of z. All are equal to equal mods. That means conjugate number also have same mod. In conjugate number simply direction is changing. Now, one very simple question is there based on this concept. So one very simple question I'm asking now again, solving, but that is also asked in previous exams. If 5z2 upon 7z1 is purely imaginary, then find value of mod of 2z1 plus 3z2 upon 2z1 minus 3z2 is equal to how much? If 5z2 upon 7z1 is purely imaginary, then we have to find value of this. So now in this, what you will do, 5z2 upon 7z1 is equal to ki, where k is any real number. So z2 upon z1 is equal to 7 upon 5 ki is equal to some constant lambda I, you can say. Lambda is equal to 7 upon 5 k, where k is any real number. So dividing this by z1. So we'll get this is equal to 2 plus 3 z2 upon z1 upon 2 minus 3 z2 upon z1, dividing by z1. So next step, we will get this is 2 plus 3 lambda I upon 2 minus 3 lambda I. So you can see both are now conjugate. They are in the form of z upon z bar. So this will be equal to 1. So answer will be 1. One more question based on these concepts. That question is, if z is equal to minus 2 plus 3i, then find value of, find modulus of e raised to power iz. What is this? Find modulus of e raised to power iz. So this must be written as e raised to power I. Z is how much? Minus 2 plus 3i. So this is equal to e raised to power minus 2i minus 3 mod. Now remember here, e raised to power I theta mod is equal to mod of cos theta plus I sin theta. So this will be always equal to under root of cos square theta plus sin square theta is equal to 1. But mod of e raised to power theta will be e raised to power theta if I is not there, because this is always positive. So this you can write e raised to power minus 2i into e raised to power minus 3. So this will be equal to e raised to power minus 3, because e raised to power minus 2i will be always 1, because its modulus is how much? E raised to power 2. Here theta is equal to minus 2. Theta can be anything. So this will be answer e raised to power minus 3. Now in the last, today I am taking properties of amplitude. Properties of amplitude. So properties of amplitude, first of all, argument of z bar is same as minus argument of z. They are almost log properties. Argument of z raised to power n is equal to n times argument of z. Now, the problem is these properties are applicable for principal values of argument. That means left hand side and right hand side both must vary between minus pi to pi. So for to adjust that, we add here plus 2k pi, so that this overall value is between minus pi to pi. Similarly, argument of every time, anytime we can add 2k pi. Z1 upon Z2 is equal to argument of Z1 minus argument of Z2. In this also we can add 2k pi anytime. Only thing is, whatever answer is coming, it must lie between minus pi to pi. Fourth, argument of Z1, Z2, Z3 is also equal to argument of Z1 like log plus argument of Z2 and so on plus 2k pi. K is any integer. This we can add anytime. So these are some important properties I have discussed today. Now in tomorrow class, I will discuss you, I think all things are we have done today. Only geometrical part is left. So next class, I will explain you the geometrical properties, geometrical applications of complex numbers. How to write straight line, circle, parabola, ellipse, etc. What is the locus, how to solve equations involving complex numbers, complex equations. So those concepts I will explain in the next class. So any doubt is there, you can ask me in today's class. If anything you have not understood, anybody? I have unmuted all of you. So Bhavya is there. Any doubt?
No, sir.
So can we find the root of a complex number, sir?
Yeah. That is why I thought you will have must have done in square
Sir,
root
it's
of
1
complex
by.
numbers.
Yes, sir.
Okay, see this. I'm explaining square roots of complex number. This last part you asked me. Square root of complex number. Okay, note down. I will give the formula also for that, and we will solve 1 or 2 questions for that. Square roots. And for roots I have given. See, if you don't know anything, suppose 3 upon 4. One question, De Moivre's theorem you can use. One question I have given, z raised to power 3 upon 4. Otherwise, for example, I will take one question, very simple question, with the help of explaining the concept of finding square roots of complex numbers. If we have to find fourth root, fifth root, we have to go for the De Moivre's theorem concept. For example, find square root of minus 5 plus 12i. Suppose this I have to find. So what I will do, I will write minus 5 plus 12i is equal to x plus iy. If I don't know, I will write just x plus iy. So minus 5 plus 12i squaring is equal to x square minus y square plus 2ixy. So I must have x square minus y square is equal to minus 5 and 2xy is equal to 12. Now from here, I can calculate x square plus y square. X square plus y square is equal to x square minus y whole square plus 4x square y square. This algebraic identity, a plus b is equal to a minus b whole square, a square plus b square is equal to a minus a square minus b square plus this whole square. Sorry, this whole square will be equal to this. Okay, so this will be how much? X square minus y square is how much? Minus 5 whole square, 25, and square of this is a plus 144, so 169. So from here you will get x square plus y square is equal to plus minus 13. So definitely it cannot be minus 13, so we will cancel this minus. So now I got two equations, x square minus y square is equal to 5 minus 5, and x square plus y square is equal to 13. Solve them. So if I add, I will get 2x square is equal to 8. So x square is equal to 4, x is equal to plus minus 2. Now this value if I put here, x square is equal to 4, y square is equal to 9, so y is equal to plus minus 3. So I will get here 4 values. My roots are x plus iy. So x is 2. So roots are 2 plus 3i, 2 minus 3i, x can be negative also, minus 2 plus 3i, or minus 2 minus 3i. Out of these 4 solutions, I have to select. All are not correct. Here concept is x and y is positive. This step is very critical. You have to check whether xy are positive or xy is negative. That means they must be of same sign. The same sign means I will reject this part, I will reject this part. So my answer is plus minus 2 plus 3i. This is the square root of this answer. So this is the way how we can find the square root of any complex number, or by observation also you can find actually. Okay, understood? Understood this?
Yes, sir.
Anything else? So we will be finishing the class now. Today you must solve all the questions are there. They are very easy problems. You must solve within time frame, 1 hour or maximum 1.5 hours. That 100 problems. 1.5 hours is the maximum time limit. To everybody. Tomorrow also one more class will be there. Subject I will tell tomorrow chemistry may be there from 2 to 4. Thank you all of you.